Okay, the topic now is inversed. Inversed. I mean, keyboard, inversed. Inverse sine, coma, cosine. Bueno, after cotangent, cosecant, pero inverse function. Inverse function. And tangent, gente. Tangent. Guys, this is a little bit complicated to understand. Pay attention, please, and focus. I try to do my best, but it's complicated, I know. Okay. Make zoom. Okay. And this is the title of today. Okay, there you go. You know very well the classical sine, cosine, tangent, cosecant, cotangent we studied in the chapter 1. This is the function. For example, I take sine only for example, but it's similar idea, similar, not exactly the same in every. Y equals sine of x. Okay. In this case, normally x is an angle, maybe in degree or in radians. Degrees plural or radian, and when you plug it in this angle and we compute the sine, y give me one value que depende, ¿no? Si es sine is between -1 and +1, and cosine is similar, but tangent no, tangent is from -infinity to +infinity. This is the idea that we studied in the chapter 1. In this chapter we studied the inverse. Inverse is exactly the same idea that we studied in college algebra. Inverse function is in another direction. Entonces, to find the inverse function, always you interchange x and y. Now is x equal sine of y. Now, if you try to represent this in explicit form, this is explicit form because this is implicit form. Implicit is when the y is not isolated, implicit form. Can nobody understand anything here? However, in explicit is clear. Y alone is the inverse function of sine. And the representation is sine inverse, que is using this -1, que actually this -1 is no exponent. No. It's symbolic way to indicate inverse function. Similar to the thing we are doing in college. But this is specific for the trigonometric function. Okay. Well, this is one way. In the history of the mathematical, there are different versions of the name of this. This is more recently way. However, we have another antique way to represent the inverse function that y equal arc sine of x. Okay, entonces you see in the book, either way, arc sine and sine inverse is the same. This is the most recently, and this is antique, but it's the same. Some people, when you take calculus, some teacher of calculus prefer the antique way, another no. See, you take with me, I prefer the sine inverse, like that. I prefer this way. But what is the interpretation? The interpretation is completely different. It's inverse. X now is no angle, is value. Because remember, you interchange x and y. Y in the original is the value, x is the angle. Now, X is the value and Y is the angle. Pero what angle? The interpretation is you have one number here. And what is the angle whose sine is something? And the information is given as angle. Okay, to understand quickly this idea. Suppose, example, clarify the idea. Suppose sine inverse of 1 is, I have no idea, ese angle que want to call theta. Entonces, one way to interpretation this is sine theta equal 1. So what is the angle whose sine is equal 1? Oh, es pi over 4, professor. Pi over 2, sorry. And that's it. This is the idea, right? Do you understand the basic idea? The basic. I want to complicate a little bit more this. Okay, do you understand? Function inverse.
Question. I'm the one who didn't understand. So, like when we have an implicit form is inverse of the explicit form, is what you mean? Because I feel like the one first is
No, exactly. It's explicit is when you isolate X, Y, sorry, when you isolate Y. Explicit is when you isolate Y. Entonces, when you isolate Y, you introduce a new symbolic way to represent this new function que es sine inverse. Correct?
Okay,
it's similar idea when you study in college algebra, exponential function and logarithmic function. And they are inverse each other, no? But you introduce new notation as log, que es logarithmic. In this case, it's the same, right?
Right, I got it. Thank you.
More clear. All right, what is the problem? What is the big problem? The big problem is, let me go to Desmos to explain one thing. Okay, you let me know, see I can switch it or not to Desmos. Chuku here, click, and click. Do you see Desmos?
Yes.
Okay, super. Look at that. This is, okay, this is my sine function. What is the reason I put in dotted line? Because I need to find the inverse function of this. But what is the first problem? The problem is that this function is not one-to-one function. Because when you apply the horizontal line test, this function fails because it crossing only more than 2 points, an infinity point cross. Therefore, this function is not one-to-one. And the professor que teach me college algebra say that to be invertible, one function must be one-to-one. Entonces, in order to convert in one-to-one, you make restriction. You take the original sine function graphic we are doing in the test number 1. No. You take only one piece. And the one piece is this piece. This piece I put in blue color. And this is the agreement, international agreement. All of the world, the people take one piece of sine que is in between negative pi over 2 and positive pi over 2. And now this line, this piece of sine, sorry, no line, is one-to-one. Therefore, it's invertible. Now it's invertible. Okay, now remember, I suppose you remember what is the traditional way to see graphically the inverse function. You take the famous line y equal x, and the inverse function is, is a reflection with respect to the line y equal x. So the purple color represent the inverse function, but we have restrictions in the domain and range. Okay, I want to explain in detail now. Okay, entonces now, so you understand, I want to delete, erase the original piece of sine, and why not this line also? And this is also the graph can represent the inverse function. Okay, do you understand? Let me recap again. The original sine function and cosine happen exactly the same, but I want to explain after. It's no one-to-one. Entonces, everyone in the world make restrictions to convert to the one-to-one. And the inverse function, the graph look like that. Okay, we come back. See, you understand this or no? Yes or no?
No, Professor.
What part no?
I didn't understand the part that you explained that you just put like, for example, you highlight first like the sign, right? The function, then you just highlight the second part. I didn't understand this part.
Okay, let me repeat the story again. The story is easy. The story is we need to find inverse function, sine inverse function. But the problem is that sine inverse function, the original that we studied in the last chapter, is no one-to-one. This idea is clear?
Yes, this part is clear, Professor.
It's clear. Therefore, this function is not invertible. Pero I need the inverse. To create that, I create restriction. I take one piece of the sine. This piece of the sine now is one-to-one. Because when you apply the horizontal line test, pass, crossing only one point. Therefore, see, this is invertible. I find the inverse function. The inverse function is a function, the graph is exactly the same, but reflecting over the line y equal x. Now it's more clear. Now the point and the inverse function is, let me erase that part, is this. Clear? This is a graph that represents sine inverse. It's the thing I try to explain. Good? I don't finish. I need more.
Okay, it's good. It's good.
It's good. It's good. I know. Okay, let's come back to the whiteboard and complete the information. Look, and let's see example. And the example little by little you understand. Whiteboard. Where is my whiteboard? Here, over there. Do you see? Entonces the restriction is the domain of this function. O sea, that function. Let me copy. Y equal sine inverse of x. It's a new function that we taught today. The domain is is from -1, include both endpoint, the x value. Remember, this function is completely backward to the sine. In sine, you plugging in angle, and this plugging in value, and you get angle. And the range, according to the restrictions, is from -π/2 to +π/2. So it's not too easy to see what is the answer in this. So one mnemonic device to remember is in this sketch. Look, this sketch is the sine inverse. Let me explain this, plus minus. The answer of the sine inverse is always positive si lie in the first quadrant, and negative si lie in the fourth quadrant. And what about Professor si lie in the second and the third? Well, we are in big trouble. Okay, I want to explain now. Look, suppose I need to compute a sine. Okay, again, sine inverse of 1/2. Oh, nice, because 1/2 lie in this interval. Entonces I need to remember what is the angle whose sine is 1/2. Well, you remember, it's perfect. Si you don't remember, okay, it's 30 degrees. Nuela is a 30 degree. Okay. Suppose that some students don't remember, no problema. But you don't remember this way, que es weird, it's a new one. You consider que es the angle, theta, I call theta. And you translate this statement to another, que es sine theta equal 1/2. Okay? Entonces now, sine theta 1/2, Nuela say que theta is equal 30 degrees. But it's also 150 degree also, right? Because in the second quadrant, sine 150 is 1/2 again. But this answer is not allowed because my range is bounded in between negative 90 degree and positive 90 degree. Okay, you take, okay, it's easy to memorize because the number inside is positive. You take the angle in the first quadrant. However, see you, the number inside the parenthesis is not positive, it's negative, like a negative 1/2. For example, I hear some noise. Who make a noise? Putting off every microphone, please. All right, let me see. I detect it quickly. Who make a noise? Cooper, Mr. Cooper. Excellent. Thank you. This is important moment, guys. Don't make a noise. Hello. Okay, see the number inside the parenthesis is negative. According to this diagram, the answer is in the fourth quadrant. Entonces es negative 30 degrees or negative pi/6. This is the problem. Never in the second, never, and never in the fourth. The answer, the thing I try to explain, que the answer que offer in the range, the inverse trigonometry sign is in between negative 90 degree here and positive 90 degree. The rest no, illegal inside. Why? Because I make restrictions, and this restriction is possible because I need the one-to-one function. Okay, this is important. I promise que you see every example of miscellaneous que combine sine inversa, cosine inversa, tangent inversa, sine no inversa, natural, ordinary sine, ordinary cosine. But this is the theoretical part I want to explain now. Okay? Another example. Suppose, bueno, sine, two couple, sine inverse of radical 3/2 and sine inverse of negative radical 2/2. Well, do you remember what angle whose sine is radical 3/2 or no? Send me the answer by the chat. What did you say? 60 degrees. 60 degree or pi/3. Super. And the number inside the parenthesis is positive. Therefore, the angle belongs to the first quadrant. But in the second example, the number here is negative. So the answer que offer the sine inverse lie in the fourth quadrant. Entonces, entonces en the fourth quadrant, always the answer que you put in the, for example, you put in the graphic calculator or you put in Symbolab. Symbolab is one tool, fantastic tool online. You want to show you your moment, no now. Symbolab. Give me the answer for any inverse and the direct trigonometric function. Is negative pi/4. Okay, negative pi/4. So actually, we have two angles. One angle, so the sine is negative in the fourth quadrant and in the third quadrant. We have in the fourth quadrant negative pi/4 or 7 pi/4. So you rotate contra-clockwise, but I don't care the value in the third quadrant because the restriction exclude third quarter and second quarter. Good. This idea is so far is clear that the answer for the sine inverse is si es positive the value inside, the angle conferred es in the first quarter. Si es negative, the angle conferred is in the fourth quarter. End the story. Good. And this is and this is always the same in any trigonometric function. No. Yeah, I want to explain. For example, cosine. Let's come back to the cosine. Cosine. Unfortunately, I need to go again to Desmos to show you cosine. Okay. Do you see Desmos now? Do you see Desmos now?
Yes, Professor.
Again, repetition the story, but quickly. It's the same, it's similar, no? Entonces, look, this is the famous cosine. No. Hello. This is the final answer. Okay. Okay, look at that. This is our cosine that everyone knows very well. Remember the cosine, the difference between cosine and sine is que cosine start in maximum positive, no? Sine no, sine start in zero. Okay. But again happen que es no one-to-one function. You take one piece of cosine. Entonces, what's the agreement, professor? But one piece I take it. Either piece, no. The mathematicians create one meeting and say the restriction is always for any country in the world, this. And between 0 and pi. This piece of cosine. Now, see, I want to see the inverse function. I put a line y equal x, and this is symmetric. Look. Wow. This, let me change the color. The black color is the function that I want to study, que es cosine. Then we have different point, is this point, 1, 0, 0, pi over 2, and negative 1, pi. Okay, so let me delete the rest of the story. Look. This is my cosine inverse function. Oh, and then my cosine inverse function is different. Because when the value inside the inverse trigonometric function, that by the way is always the same between 1 and negative 1 or negative 1 and 1, is positive, the answer of the cosine inverse, give me an angle in the first quarter. Nice, I understand now. However, when it's negative, give me the angle que lie in the second quarter. And you see, wow, professor, this is crazy. Well, it's not crazy, it's a mathematics. Okay, so now you need to memorize. Que in the cosine inverse, que es the same idea, this is cosine inverse. The idea is this, positive and negative. Let me make it zoom to see more clear. Okay, when it's negative, the answer is in the second quarter. Sorry. Thank you. Thank you so much. You are the best. Okay, thank you. So the idea I want to convey is, look, cosine inverse, when the value you plug it inside is negative, the answer is in the second quarter. When the answer is the number inside is positive, the answer is in the first quarter. ¿Tú dónde estamos?
See the white.
Whiteboard, no?
I still don't.
Say again?
I do not see the white.
You don't? Okay, let me check it out again. Everyone saw the whiteboard or no?
Yeah, I can see it.
Entonces your problem is.
Okay, I'll reload.
Okay, reload, no? It's a solution or go out and get it inside again. Okay, entonces, okay, this is confusing. So never here, and never here. Only first quadrant or second quadrant. Suppose cosine inverse of the 1/2. Entonces, my question is, I know que the answer is the angle theta. Okay, si you want to see more clear, because I am not familiar with the cosine inverse, I write like that, cosine theta equal 1/2. Entonces, my question is, what is the angle theta whose cosine is 1/2? Help me.
It's 60.
It's 60 degree. It's 60 degree or pi over 6. Super fantastic. Or pi over 3, no? However, si I want to complicate your life, I put cosine inverse of negative 1/2. Cosine inverse of negative 1/2. Oh, entonces now, dice cosine theta equal negative 1/2. Y I know que cosine is negative in the second quadrant y in the third quadrant. However, according to the restrictions of the inverse trigonometric function, the answer que I get is in the second quadrant, no? O sea, here, in the second quadrant. Okay, in the second quadrant. Okay, by the way, the same value of the trigonometric function, half is 60 degree, no? So 60 degree would be the reference angle, 60 degree. Therefore, this angle is 120 degree. Make sense? So the answer for theta is 120 degree or 2 pi over 3. Is the answer for this problem. Sorry, the answer for this is 60 degree or pi over 3. Either way que you prefer. 120 degree or 2 pi over 3. Either way. Do you understand very well or no? Entonces tú dices, no, profesor, this is crazy. No, because...
No, I didn't get it.
Look. Let me summarize the idea. The idea is, I want to raise the board or no? No? Not yet?
No, Professor, because I didn't understand this last
No,
part.
I want to, you didn't understand? Okay, good. What part you don't understand?
Like, Professor, why the sign of angle is, why the angle is 120? I didn't understand the sign of it.
Okay, do you see que this value and this value is the same, except the sign, no?
Yes, Professor.
And this is perfect characteristic of the reference angle, no? Remember, reference angle is the same value, but according to the sign, you adjust the quadrant, no? In this case, entonces I suppose que es...
Okay, I got it, Professor.
Oh, okay. Okay, let me summarize, but don't complicate too much this. What is the shortcut that every student memorize quickly? Is this. We have the collection of the trigonometric functions, sine inverse, cosine inverse, tangent inverse. Okay, if you want, I show you in Desmos also, or no. It's not important to see the graph. You trust to me, I suppose, no? Okay. And the idea is, any positive value you plug inside in the domain, in the argument of the sign, si es positive, lie here. The angle conferred is in the first quadrant. Si es negative, lie in the fourth quadrant. And never we get value in second and third. No. Cosine, well. Cosine is a little bit different. Okay, it's a little bit different. It's like that. When the number that you plug in here and the argument of the cosine is positive, well, the answer that you get is the angle, but lie in the first quadrant. Nice, I like that. However, you plug in one value que es negative, the answer that you get is in the second quadrant. And never en the, what is the 120? 120 en the second quarter, ¿no? 120 es en the second quarter, ¿no? O sea, to matching this example, the example que I did before, que es cosine inverse of negative 1/2. Yes, no la dice, yes. Es 120 que lie in the second quarter here, over there. Super good. What about tangent, guys? Tangent inverse. Okay, super. Okay, now, fortunately, tangent and the sine is the same. Wow. It's the same agreement. It's the same agreement. Not necessary to write another. And secant is the same and cosecant. Ok, entonces sine, tangent, secant and cosecant. You plug it in, positive value, the angle that you obtain after the computation secant or cosecant or inverse, sorry, inverse. We are talking about inverse function. Es en the first quadrant, si es positive, y si es negative en the fourth quadrant. Ok, entonces, we never expect answer in the third quadrant. That this is totally stupid, 240 degree. No, 240 degree lie in the third quadrant. No, it's illegal, you know? And what about cotangent? Well, cotangent is unbelievable, but it's true. It's similar agreement with the cosine. And it's the only thing you should know. Okay, entonces I erase this because it's not necessary. Okay, let's move in to example. I bring several examples here. Here I try to do. Okay, let me see. Say I bring more. Yeah, I bring more. Wow, a lot. Okay. Compute it by hand without calculator. Sine inverse of 0. This is example 1. What is the idea? The idea is okay. The thing I try to find is sine inverse. Sine inverse, give me angle. I don't know if this idea is good for you. You put theta like an angle. Immediately I am familiar. Theta is angle. I switching to the another equivalent idea que es sine theta equals 0. Entonces, what is the angle whose sine is 0? What is the angle whose sine is 0? No? No clear? No clear? You don't know by memory this or no? Not yet. It's 0.
No, Professor, I just know 30, 45, and 70.
No, using the table. Theta is 0. 0 degree, no? Or 0 radian. And the answer is, in this problem, is 0. Correct?
Yes, it is.
Okay. Cosine inverse of 1. Theta. Entonces, my question is cosine theta equal 1. What is the angle whose cosine is equal 1?
90, Professor.
90 degree?
No, 90 is 0. No.
It's 0 again. It's 0 again. The cosine 0 is 1. Sine 0 is 0. Tangent 0 is 0. Okay. Now, one more example. Sine inverse of negative 1. Sine inverse of negative 1. We are working with the new function that we studied today, que es trigonometric inverse function, sine inverse. It's equal 1 angle, okay, I have no idea. Theta. So you rearrange this using the non-inverse function, que es confusing for me, sino sine. Sine theta equal negative 1. My question now is more clear, is what is the angle whose sine is -1?
180.
Say again?
180.
180?
Yes,
No.
Professor. No?
It's 270, no?
270. Very well. 270 degrees. Super. 270 degrees. Okay, guys, little by little, you memorize this. Little by
Professor,
little.
this is sine or cos? Oh, it's sine. Okay, sorry.
It's sine. Yeah. It's sine. One more easy. This is the easy. Now I want to complicate more this. Now cosine inverse pi. Or 180, either way. Degree of radian, you know. Frequently we interchange this. And I'm crazy. -1. Cosine inverse -1. Remember, inside the argument of the trigonometric inverse function, we have value, no angle. And the answer que they offer is angle, theta. You see more clear, you put cosine theta equal -1. Entonces, my question is, what is the angle whose cosine is -1?
90?
No. Cosine 90 is 0.
It's 180.
180. You understand a little bit or no? Well, you understand. The problem is you don't remember the trigonometric function, huh?
Yes, it is.
Yeah,
Professor.
okay. I understand it's a process. And I predict, because sometimes happen, some students go to calculus and don't memorize this. So the teacher in the calculus say, wow, you're stupid guys. Okay? I remember when they take calculus when I was a student, I don't know, 50 years ago, 50 something years ago. Okay, I remember very well the trigonometric function because I studied in the high school good. However, some students beside me say, wow, you are a genius. No, you are stupid, man, right? So now the teacher que explain calculus, suppose que you need to know by memory this, like a multiplication table. Okay, pero it's a process, I understand. Don't frustrate. We go forward. Entonces I want to complicate your life. Whoa, what is the complication, professor? Bueno, the complication es que maybe in the test, y in the calculus, y in the other subject, we mix it, the trigonometric function, inverse and direct trigonometric function. Suppose this example, que este combination, it's a composite function, no? Remember in algebra, F composition G, you remember that or no? Composition function, it's two functions together, right?
Right, to introduce one and another.
Yes. Suppose the example one, Nuela. Sine, parenthesis, tangent inverse of 1/2. We have the composition. You have a composition, one trigonometric inverse, que es tangent inverse, and we have sine, que es no inverse function, it's direct trigonometric function. Let me analyze. This is the value. The answer that we get in that part is an angle. And this angle, plug it in the sine, and you get another value. Do you understand the procedure?
Yes.
Okay. But I need to discover the value. So value, angle, value. This is the change. The change is value. Value. Angle. Again. Value. This is U. Okay. So you understand this? No problem. So let's do it step by step. And be careful with the restrictions or the tangent inverse. I call this guy theta because I know that this answer is the angle. So tangent inverse of the 1/2 is equal to theta, que es equivalent to say tangent theta, this is theta, equal 1. Okay, this is not, unfortunately, the typical fundamental angle that we study, 30, 45, no. Entonces, one possibility is put it in the calculator, no? But in this case, no necessary calculator, because we can use a triangle, okay? This is my auxiliary triangle, okay, help me to understand any trigonometric function, no? This is a right triangle, this is my famous theta, and 1/2, and I know by definition okay, tangent is opposite over adjacent, yes or no? You want to find sine, so you need to find hypotenuse. And hypotenuse is square root this guy, get 4 plus 1, is radical 5. Okay, is radical 5. Therefore, sine theta is opposite, is 1 over hypotenuse, is radical 5, rationalize, radical 5, radical 5. The answer is radical 5 over 5. End the story. This is the answer. Do you follow me?
Yes, Professor.
Okay. Okay, this is the first example, no? Always the first example is easy. I want to complicate more. Okay, entonces es step by step, es a sequence, ¿no? Value, angle, value. Angle, value, angle, again. Number 2 example. Number 2 example. Number 2 example is cosine, sine inverse of the negative 1/3. Wow. When it's negative, it's complicated. Because, okay, you copy. Sine inverse of a negative 1/3 equal angle. This is equivalent. Sine theta equal negative 1/3. Yeah, I remember that the professor explained the sine inverse working like that. It's positive in the first quadrant, but it's negative in the fourth quadrant. Now that angle I need to find is in the fourth quadrant. Look, this guy is in the fourth quadrant. Because the clue is this negative. Okay. However, I have no idea. I put in my triangle because this sign is not equal the sign that you know in the table que 1/2 radical 3 over 3. No, it's 1/3. This is weird. Entonces we using calculator or using the famous triangle. No? And sine by definition is opposite. This is theta, sorry. 1 over hypotenuse 3, no? And you need to find another let. Okay, maybe we need it for the cosine part. Entonces es square root 9 minus 1, que es radical 8, and radical 8 is 2 radical 2 rationalize. Bueno, rationalize no. A is 2 and 4, and square root 4 is 2 outside. Therefore, the cosine of the theta angle is adjacent, que es 2 radical 2, divided by hypotenuse, que es 3. And that's it. ¿Es positive or es negative? Well. What do you think? En what quadrant lie theta? Theta lie in what quadrant, guys?
The fourth.
In the fourth quadrant. Very well. Excellent. According to this restriction, lie in the fourth quadrant because this value is negative. Y I know very well que in the fourth quadrant cosine is positive or negative.
It's negative. It's negative.
No. All students take calculus. All students take calculus. And this indicate it's cosine positive. Yes or no?
Professor, you said sine or cosine?
Cosine.
Sorry, it's
No. Okay. What is the final answer, Noela?
It's
okay,
positive.
Oh, it's positive. It's positive because cosine in the fourth quadrant is positive. Final answer. Okay, let me summarize. Let me summarize. So you take the innermost operation, que es sine inversa equal negative 1/3. Okay, using this information, I get two pieces of information. Information number one, my angle theta lie in the fourth quadrant. Yes or no? Because it's negative. According to the convention of the sine inverse sines. Look, this is a convention sine inverse sine. Piece number two. Bueno, I know que the triangle is 1 and 3 because the sine is the ratio between opposite and hypotenuse. Okay, super. Now I detecting or find the third side, que es 2 radical 2. Entonces I am ready to set out the cosine. Cosine by definition is adjacent over hypotenuse. 2 radical 2 over 3. Oh, stop. What about the sine of this cosine? Oh, theta lie in the fourth quadrant. Yeah, I know very well que cosine in the fourth quadrant is positive. End the story. Good or not good? I know it gets too many details, but this is a training, little by little, right?
Okay.
In my opinion, this is the hard part of the trigonometric. Okay, this is a tangent, and this is cosine inverse. Cosine inverse of negative 1 over 3. Okay, little by little. I know que es value, angle, value. Entonces es theta, let me see, cosine, negative 1/3 is equal theta, que es equivalent to say cosine theta is equal negative 1/3. Wow, again, I saw the agreement of the cosine inverse, que is when it's positive in the first quadrant, but when it's negative in the second quadrant. Super fantastic conclusion. Theta lie in what quadrant? Theta lie in which, in what quadrant?
Second.
Second. Okay, now my famous triangle, que I don't care. So you see, independent of the sign, get positive or negative, I put like that always. No, some people prefer put like that. No. Crazy. The sign you adjust according to the quadrant. No, in the geometry. Hello, no. This is crazy. Because always, this is the shape of my triangle. This is theta. And this is the ratio between adjacent, que es 1, and hypotenuse 3. Correct?
Correct.
And this is the square root. This is 9 minus 1, que es exactly the same as 2 radical 2. Es 2 radical 2. Entonces now, tangent, que is the outermost trigonometric function, because I did the part inside. You detected the quadrant, you are doing the triangle. Now, tangent theta is equal opposite, que es 2 radical 2 over 1. Entonces 2 radical 2 over nothing, because 1 is invisible, no? And what about the sign? What sign, positive or negative?
Negative.
Exactly, because I know very well que tangent is negative in the second quadrant. Boom, end the story. Guys, the thing that we are studying is combination. Trigonometric function and inverse trigonometric function, que is the thing that we study. We can compute separately, but we put together, okay, to complicate more your life, no? Number 4. Number 4 is cosine of sine inverse of radical 2 over 2. Okay, I need help. What should I do? Value, angle, value, no? Okay, and then I write sine inverse of radical 2 over 2 equal theta. Therefore, this is equivalent to say sine theta equal radical 2 over 2. Entonces, okay. Entonces, we need to do the triangle. No, because I know radical 2 over 2 is the typical angle que I know in the table. Entonces, what is the angle whose sine is radical 2 over 2? Help me.
45.
45. So theta is 45. But in the first quadrant or on the fourth quadrant? Remember the agreement of the sine is something like that. It's positive. This is sine inverse agreement. In this case, the number get radical 2 over 2 is positive. Therefore, lie in the first quadrant. F 45 degree. Now, finally, cosine 45 degree is, by coincidence, radical 2 over 2, but it's positive or negative?
It's negative.
Why? In what quadrant lie 45?
On the first.
Entonces, in the first quadrant, all trigonometric functions are positive.
Everybody's positive, sorry.
No, it's okay. You are learning now in this moment. And the Desmos. And the Desmos you have to do well. Okay, number 5. Look like complicated. Weird. Sine, cosine, inverse of 1/2. Okay, let's try. Cosine, you start always for the innermost function, in this case the trigonometric inverse. Would be in the opposite direction, would be, but no, it's the most common. And cosine inverse of 1/2 is theta, ese angle. And cosine theta is equal to 1/2. Who is theta?
It's 30 degrees.
30 degrees, no.
60.
No, it's cosine. It's cosine. It's
60 degrees. 60 degrees. And what quadrant lie?
First
quadrant. Remember, the trigonometric function that we are working is cosine inverse. The diagram of the cosine inverse agreement is this. On the positive is the first quadrant, on the negative second quadrant. It's 60. Entonces, sine 60. What is the sine 60?
on the first one, so it's positive.
And the value is radical 3 over 2. Boom. Final answer. Good or good?
Yeah, it's good.
Well, little by little, you practice. Okay, 6 is tangent cosine inverse of negative. When you see negative, I am super scared. But okay, don't worry. Entonces, I declare cosine inverse negative radical 3 over 2, la que theta, ¿no? Que es equivalent to say que cosine theta is a minus radical 3 over 2. Entonces, according to the convention of the cosine inverse function, when it's positive in the first quadrant, but when it's negative in the second quadrant. Therefore, theta lie in the second quadrant. And what value is what? What value?
30 degrees, right?
What did you say? 30 degrees?
Yeah.
No. In the second quadrant, correct? Yes or no?
Yes, it's on the second one.
In the second quadrant, 135 degrees, you say? Or 150 degrees?
No,
What is it?
It's 120.
120. No. 120 is 1/2.
it's 150.
150. And 150. So, guy, you need to remember this. Oh, I don't know. You have calculator, no? Everyone have calculator, no?
Yes, Professor.
You put in a calculator.
I think I'll take my table because I think it is on the table, right?
Yeah. You're using everything. using table, using calculator, using the brain, of course. Okay? Entonces es 150, 150, 150, 150. And finally, I need to compute tangent 150, no? And tangent 150, I have no idea. 150 lie here in this quadrant, no? Here, 150. But I know the idea for the reference angle, no? Do you remember the reference angle? Is my frame? Okay, this angle alpha. Who is alpha? Who is alpha in this example?
30.
Who is alpha? 30, very well. Entonces I know very well que tangent 150 and tangent 30 at least is the same value, que es radical 3 over 3. I don't know si you see it in your table or no.
Yes.
And what about the sign? Is positive or negative? It's the same value. This is the crucial moment in which you adjust the sign.
Negative.
Exactly. Because I know very well que in the second quadrant the tangent is negative. All students take calculus. Okay? In the second quadrant, the only guy que es positive is sine. Tangent no. Tangent is negative. Wow. Too much. Pero it's okay. You have to learn this. And this is just the beginning in the chapter 2. Chapter 2 is hard. I recommend you start as soon as possible the homework. On Wednesday, you start. The homework is posted and the test too. But no, you are doing the homework. You try to make sure that your homework is good. Using the tutor or me. And when you are ready to see you, start the test. Okay, now. Suppose this example, que es tangent. Tangent sine inverse of negative 1/2. Again, the same weird idea cuando es negative. Entonces, sine inverse of negative 1/2, ese ángulo. This is equivalent to say sine theta is equal to negative 1/2. I come back to the agreement of the sine inverse. Sine inverse when the value is negative, and no, make mistake. Is this? It's negative in the fourth quadrant, plus when is the first quadrant. But in this specific example, negative the value. Therefore, that indicates me that we are in the fourth quadrant. Okay, so you declare here in one piece of paper, theta lie in the fourth quadrant. Okay, entonces the 1/2 sound familiar. Okay, es, I know, okay, es, I suppose que es ese angle in the fourth quadrant like that, boom, or like that, because we can represent using counterclockwise or clockwise. I prefer, in this part, I prefer clockwise. It is negative something. Entonces, this is alpha. Alpha is in the first quadrant, que es 30 degrees, no? So what is the angle whose sine is 1/2? I don't care the sine now. So sine, I know que sine 30 degrees is 1/2. Yes or no?
Yes.
Entonces 30 degrees is actually is negative 30. So my theta in the fourth quadrant is minus 30 degrees. So I prefer negative now in this chapter. But you know que es equivalent 330 degrees when you rotate counterclockwise. Okay. Now I finish no, and I compute tangent. Tangent what? Tangent negative 30, no? Oh, easy. You don't need to memorize anything because the negative side I put inside, I put outside, because I know very well that tangent is odd function. And tangent 30 degrees is radical 3 over 3 negative. Boom, I finish.
So, Professor, in this way is way easier because we just need to put, like, for example, if we have square of 2 over 2 is 45, right? If we have a negative, we can use 45 rather than go to the table.
Sometimes, Noela, no. When you have another value, okay, don't belong to the table. Like a 1/3, 2/3, like a 7. Entonces you are doing the triangle, and that's it.
Oh, okay, so we have to, when we have like the values that are on the table, we can use like the
Yeah.
Okay, gotcha. Thank you.
At the beginning, when you study trigonometric function, we focus in the fundamental angle. 0, 30, 45, 60, 90, ese es fundamental. But in the middle, we have infinity angle, no? And to say this infinity angle, so you need to find trigonometric function in this. We cannot use the table. You're using the calculator. And the calculator, depending the kind of calculators, you have more sophisticated calculator. Some calculator give me exact answer. And the majority of calculator cheaper give me a decimal approximation. But in this case, we are doing by hand, a little bit by hand. No? When you have a no typical value that belong to the table, to say now you compute the trigonometric table using the triangle. Okay? Triangle. Okay, one more. Suppose. Okay, we have secant. Secant, ahí. Secant cosine inverse of 1/2. Compute that. Cosine inverse 1/2 equal theta. It's equivalent to say cosine theta equal 1/2. And the agreement for the cosine inverse is something like that. Cosine inverse agreement. Positive first quadrant, negative second quadrant. The value is positive. Nice. Entonces, I detect immediately que theta lie in the first quadrant. Nice, because any trigonometric function in the first quadrant is positive. Do you remember some angle? Whose cosine is 1/2? Oh no. What is that? 60. No.
You said cosine or cosine, Professor? Sorry.
Cosine.
It's 60. Yeah, you're right, Professor.
60. So entonces I discover, wow, my theta is 60 and lie in the first quadrant. Okay, and the rest is compute the secant 60. Well, I don't remember. I know que es recíproca cosine. Y I know que cosine is 1/2. And reciprocal 1/2 is 2. Is the answer. And the answer is positive or negative? Es positive or negative?
It's negative.
How do you know it's positive? What is the clue? Because exactly, because she said, because lie in the first quadrant, professor. Okay, one more, cotangent now. I mix it together, guys. Trigonometric direct function and trigonometric inverse function. Okay, there you go. Come on, spend time and give me an answer. Try. Exactly the same I do. You copy the innermost, que es sine versus.
Cosine is going to be negative 60.
Negative 60, all right, negative 60. Okay, negative 60. The negative 60 lie. But negative 60, yeah. Negative 60 or negative 30?
It's sine 30.
30, no?
Yeah, I'm trying to memorize, Professor.
Okay, that's the conclusion. Theta lie, and what quadrant lie?
The first.
No. According to the agreement of the sine.
Yes, it's, Jesus. This is really hard to
Lie in the fourth quadrant, correct?
Yes, because
and you say que es negative 30 degrees, no? or
Yes.
pi over 6, either way. Entonces, finally, cotangent, negative 30 degrees, is equal to minus cotangent, 30 degrees. Because cotangent is also odd function. And cotangent, I have no idea, I don't remember, is the reciprocal tangent. Y I know que tangent is radical 3 over 3, ¿no?
Yes.
Entonces now, flip it, es negative 3 over radical 3, ¿no? Rationalize is negative 3 radical 3 divided by 3 is negative radical 3. It makes sense because my angle lie in the fourth quadrant, and the cotangent is negative in the fourth quadrant.
Professor, can I ask you a question?
Go ahead.
The thing that makes me confused is like after we find like the angle, like we find negative 30, right, Professor? We need to go back to the shortcut that you gave us. That sine.
Yes, you're right. This is the procedure. This is the procedure.
Oh my God! Because then you need to then when you at the end you need to go to the table and see if it's like on the Jesus Christ. This is really hard to memorize, Professor.
Because okay, in this case we are doing the first action is the trigonometry inverse function. So when you get the quadrant and you get the angle, you go to the table. The table give me the regular direct trigonometry function, no? Makes sense?
Yes, it makes sense. It makes sense. It's just me that I'm confused, but I understood, Professor.
Of course, it's a process. Cosecant now. Cosecant. Tangent inverse of 1. Wow. Tangent inverse of 1. Cosecant. Uy. Entonces es tangent inverse of 1 is equal to theta, ¿no? Que es equivalent to say tangent theta equal 1. Entonces, what is the angle whose tangent is 1? Y in what quadrant lie? The convention for the tangent inverse is like that. This is tangent inverse. Si the value is positive, is in the first quadrant. Si the value is negative, is in the fourth quadrant. This is so because theta lie in the first quadrant, no?
45, Professor.
45, very well, 45 degrees. We discovered que 45 degrees, and the rest is piece okay. Cosecant 45 degrees is the reciprocal sine, 45 degrees. And sine 45 degrees is radical 2 over 2, no?
Yes.
2 over 2, flip that, it's 2 radical 2, rationalize, radical 2, radical 2. Is 2 radical 2 divided by 2 is radical 2. Wow, radical 2. And the sign is positive or negative? It's positive or negative?
Positive.
Why? What is the reason it's positive?
Because it's
because lie in the first quadrant, my angle.
Yes, it's all of them are positive.
Yes, all is positive. One more, that's it. Let me try to find one complicated for you. Cosine is the last one, I promise. Sine inverse of negative radical 3 over 2. Okay. So you take the innermost function, que es sine inverse negative radical 3 over 2. You call theta, because I know that the answer is the angle. If you want to understand much better, you transform it to direct trigonometric function. Okay, entonces now immediately I recall the restrictions of the sine inverse function. Que you know, si the value que you plug in inside is positive in the first quadrant, pero si es negative is in the fourth quadrant. Entonces theta lie in the fourth quadrant. Excellent. Therefore, what angle you know que es radical 3 over 2 the sine? When I remember
60.
60, pero 60 Positive 60 or negative 60?
Negative.
Excellent. Theta is negative 60 degrees. And flowing in cosine, negative 60 degrees. I know that cosine is even function, entonces disappear el negative. Es cosine 60 degrees. And cosine 60 degrees is 1/2, no? Done. End the story. We are the best. That's it. Time is over, eh? Remember, guys, today is the last day. Let me stop recording. It's the last day to